Welcome to exercise 9D, which is linear inequalities. You may not have done this before, so you might have to watch this a couple of times and refer to this as you're doing the homework. Anyway, let's get started. So, the main, I guess we get introduced to inequalities. Inequalities refers to, as opposed to the equal sign, which tells you x is definitely equal to one number. X is equal to 5, for example. With inequalities, when we want to refer to a range that x is bigger than 5, could be anything. We don't know what it is, but it could be anything bigger than 5. Then, or x is less than 5. Or maybe x is equal to 5 or more than 5, either of the two, or the other way around, less than or equal to. Anyways, that's what inequality basically refers to. And so there are 4 inequality signs. And let me just pull out my pen. And so this sign means less than. It means less than. So if you have, for example, like that, then we would read this as 3 is less than 5. And I guess there's a few ways people think about it, I guess, if you want to remember to differentiate between that and that. You get used to it, but for the time being, you can think of it as, see how this is opening up and it's a bigger space, I suppose. So 5 is bigger and 3 is smaller because it's closed. 3 is less space over here. And I don't know, people think of it different ways. And this obviously means is greater than or is more than. So for example, if you have 5 is greater than 3, note that 5 is pointing towards 3, so to speak. You can think of it as like an arrow if you want. That's another way to think of it. 5 is pointing towards 3. And of course, older people are allowed to point at younger people, but it's rude for younger people to point at older people. That's how you can remember it if you want. So bigger numbers point towards smaller numbers, if you want to think of it like that. Regardless, so you have 4 different signs that x is greater than 5. Obviously, read x is greater than 5. And the way we represent that on the number line is you draw a circle at 5. And then because it's greater, it's pointing to the right, we draw arrow to the right, going like that. And this means x is greater than or equal to. Could be equal to. Notice there's kind of like an equal sign there. Or it could be greater than. So it's both greater than or equal to. And the way we do that is we draw a circle at 5, but we color it in. So if we want to include 5, it's colored in. If we do not want to include 5, it's an empty circle. And this is x is less than 5, x is less than or equal to 5. So let's look at this in practice. Write each graph as an inequality. So we know it's definitely got to do with 2. Now x, the colored in, the shaded in bit, is more than 2. It could be 3, it could be 4, it could be 5. X is more than 2. Now it is an empty circle, so it's not more than or equal to, it's just greater than 2. X is greater than 2. And that's how we do it. Over here, now it's going to be something to do with -1, and it's less than -1. So x can take on any value that's in the red arrow. So x could be -1, could be -2, could be -3. And this arrow signifies anything less than. So x could be anything less than or equal to -1. It's less than or equal to because it is a filled in circle. It's a filled in circle. And from -1, we're pointing towards the left-hand side. That's why, it's like that. Let's look at another question. Write each of the following as an inequality and then show each solution on a number line. So we have to write x is less than or equal to 3. So we write x is less than or equal to 3. And it's just a matter of memorizing the symbols, perhaps. Finding a system which will let you memorize these symbols. You just have to learn them. I've shown you 2 or 3 different ways to remember them, I guess. But yeah, it's really just a matter of that. X is greater than 1, so x is greater than 1. X is less than 0, so you have x less than 0. And then we have x is greater than or equal to -2. So x is greater than or equal to -2. Yeah, so just knowing what the symbols are. Solve the following and show your solution on number line. Okay, so the thing with inequalities is you can also solve them. You treat them kind of like equations, which is why they're in this chapter, because this chapter is all about equations. And there is one caveat, there is one exception, and we'll get to that in a bit. But for the time being, we treat it just like a normal equation. Everything is the same, except for one thing. And we'll get to that in a bit. But for the time being, we are just going to treat this like a normal equation to solve it, okay? So for example, here's 2x minus 1 is greater than 17. So we're going to add 1 to both sides, and we'll have 2x greater than 17 plus 1 is 18. Now we're going to divide both sides by 2. And so we have, that's going to cancel out just with x. 18 divided by 2 is 9. And then we'll draw a number line real quick. And it's going to be greater than 9. So we write 9 there. We write 10 there. We can write 8 here. And don't really have to write anything else. Now it's x is greater than 9. So we'll draw an empty circle here. An empty circle. And it's greater than pointing to the right. So we just draw an arrow like this. And I'm done. That's it. So we have I've given a numerical solution, and I've also graphed it. And show your solution on a number line. And I've graphed it like this. Now let's do B. Exactly the same thing. We're going to multiply both sides by 3 here. Multiply both sides by 3. I'm treating exactly the same as I would any normal equation. So x is less than or equal to -2 times 3 is -6. And then as far as the number line is concerned, draw a line in the middle. You put that number, -6, put a -6, put a number on either side. So you have -5 here, you have -7 there, draw an arrow, draw an arrow. And that's really all you really need to do. And now it's -6 and it's less than or equal to. So I'm going to I'm going to draw in a filled circle, draw a circle, shade it in, fill it in. Okay, filled it in. And it's pointing to the left, less than -6. So just draw an arrow like this, like that, and I'm done. And look, you can draw it a few different ways. If you want to, you can draw a number line like this as well. And you can fill it in like that if you want. But I find like this way is the easiest. It's just simple. Just draw one arrow. Don't have to fill anything in, and you're done. Okay, moving on. Now, as with before, I'm going to solve this just like I would a normal equation. Now, observe the one exception that you need to keep in mind, okay? So I'm going to subtract 4 on both sides, -4 there, -4 there. And so you're left with -x greater than or equal to 6 minus 4 is 2. Now, listen carefully. The big difference between equations and inequalities. Listen carefully. And you know what? I'm going to write in red, because there's always some student who somehow manages to miss the only thing, the only difference, right? If you multiply or divide all terms on both sides, I should say, both sides. If you multiply, divide all terms on both sides by a negative number, then flip the sign. And you know what? I just tidied it up, and I'll explain what I mean in a second. That should be capitalized. Flip the sign. And that's the only rule. That's the only difference, okay? If you multiply or divide all terms on both sides by a negative number, then flip the sign. So over here, to continue solving my problem, I'm going to multiply both sides by -1, because I don't want to know what -x is greater than or equal to. I want to know what x is greater than or equal to, or less than or equal to, or whatever. I'm trying to solve that inequality. So I'm going to multiply or divide by a negative number. I'm multiplying by -1 here to flip the sign, because I know if I multiply anything by -1, the sign flips. -x times -1 gives me x. Now, notice over here, it was greater than or equal to. Because I've multiplied or divided all terms on both sides by a negative number, I have to flip the sign. If it's pointing to the right, it's now pointing to the left. That is the only difference between equations and inequalities. Every other way, they're exactly the same. But if you multiply or divide by a negative number, any negative number, multiply or divide, doesn't matter. If you multiply or divide by a negative number, flip the sign. That's it. That is the only difference. Make sure you understand that, okay? I'm making it very, very clear. If you multiply, divide by a negative number, flip the sign. And apart from that, inequations are exactly the same as equations. Anyway, I hope I was very clear there. I tried my best to be. So we have -2, write -2 here, write the number on either side, -3, draw an arrow, and then -2 is where I'm at. So I'm going to draw a circle there. It is less than or equal to, so I fill it in the circle. Okay, and it's pointing to the left, right? It's pointing to the left, so I just draw an arrow that way. And I'm done. So that's really it for this exercise. It will be quite a bit different, perhaps, to what you've done before. I'm not sure if you've done this before or not. Anyway, best of luck with it. This video will be up on YouTube, and you may have to refer to it as you do the homework. Please make sure you are doing some of the harder stuff as well. So that means that you should definitely be doing the problem solving and reasoning, more specifically questions 8 and 9, as well as question 11. Definitely 8 and 9, because how else are you going to learn? If you don't do the work, how are you going to learn? So please do 8 and 9. You may want to do 10 as well. That's kind of optional. That's only if you want to really get ready for next year, I guess. But yeah, 8 and 9 as marked in textbook. Just do 8 and 9 as marked in textbook. All right, so I'll entertain question now for the people who are on Zoom, and I'm stopping the recording.